This is Heidi Kuzma.
Hello, everyone. Welcome to our panel discussion where we will be exploring how artificial intelligence can support the needs of CTBTO. My name is Megan Slinkard. I will be your moderator today. I am not Heidi Kuzma, however. Heidi had a flight cancellation issue and will not be able to join us in person, at least today. Allow me to introduce our panel. To my left here, we have Dr. Karti Teknomo, who is an associate professor in computer science in Ateneo de Manila University in the Philippines. His research interests are in transportation, data science, and artificial intelligence. He is the main researcher behind the Techno-Fernandez algorithm, the queuing rule of thumb, and the ideal flow network. To his left, we have Dr. Korhan Shami, who is a researcher in seismology working at Boğaziçi University Kondili Observatory and the Turkish NDC. His research interests are in waveform correlation using seismic arrays and in the discrimination of earthquakes and explosions. Lastly, we have Dr. Stuart Russell, who is a professor of electrical engineering and computer science at the University of California, Berkeley, where he is the director of the Center for Human-Compatible Artificial Intelligence. For those of us who have taken artificial intelligence classes at the university, we generally know him as the guy that wrote the book. His textbook has been used by over 1,400 universities in 128 countries. He has worked with CTBTO since 2009 and originated the NetVisa Bayesian monitoring system. We will manage our time today by first hearing from Heidi Kuzma using the wonders of modern technology. She was kind enough to record herself giving her presentation, which will do a wonderful job of framing our discussion today. Then I will have each panelist give a short presentation where they'll explain from their vantage point how artificial intelligence can best engage with the needs of CTBTO. At that point, we will open things up for questions. It is my understanding that the mobile app is not activated for this session, so please notate your questions and be prepared to ask questions from the floor. I think we will have an interesting, engaging discussion ahead of us today, looking at how artificial intelligence can improve accuracy and efficiency for the data processing needs here at the IDC. Now we'll have Dr. Teknomo speak a little bit about his research.
Thank you. It's an honor to be here. I would like to start with the framework on how AI can be used to help the work of CTBTO. The main idea is this. I believe CTBTO should see AI as a process rather than a series of projects. The goal of the AI process are continuous improvement and continuous discoveries. As the countries with nuclear weapons can be seen as intelligent agents, they also evolve. Knowing the standard international monitoring system in CTBTO, it will become a cat and mouse game for these countries to go undetected from the monitoring system. Abstracting the simplified AI process, we can see 5 components in sequence of data fusion, feature selection, machine learning, multi-agent systems, and AI applications. In reality, this process consists of various feedback which can make the later process back to the earlier process. Let us now see each component in more detail. In data fusion, we have to unify data, features, and models from various sensing devices: seismic, hydroacoustic, infrasound, radionuclei, and future unknown devices. These sensors produce raw data which should be filtered from noise through some models, for example, low-pass filter. Then, the data will be derived into more meaningful derived data, such as P-wave and S-wave in level 1. And in higher level derived data, we may have velocity, acceleration, angle, distance, depth, magnitude, and through triangulation model, we can also derive location and other features. Now, in feature selection, we pick only the relevant features, data, and model by removing redundancies and correlated data. The goal is to understand the behavior and the underlying phenomena behind the event. The heart of AI process is in machine learning. In here, we have a model with a given input and output, and through learning process or model calibration, we produce the parameters. Assuming the models and the parameters are invariant, no change, we can predict the output for the given input, or we can control or optimize the input from the given output or the goals. When the output are discrete or categories, we have classification models. When the output are continuous or real numbers, we have regression model. For the classification models, when the label of the categories are given, we have supervised model. Neural network, including deep learning, is one of the supervised model. As manually labeled category, such as man-made event or natural event, can be expensive, we may go into what is called semi-supervised learning. In here, the model is trained with a few data in supervised way, then it can automatically find the next label by itself. Ideal flow network, or IFN, is one example of the semi-supervised learning. I can show you the short video later after the presentation. Then we may also have let the model to find the label of the categories on itself based on what is called unsupervised learning model, which is basically based on distance. Now, if we use agent-based, we will have a reinforcement learning. Now, in all of these, the question remains, how are we going to get the ground truth data? Now, distributed AI or multi-agent system can help the CTBTO in thinking each part of AI system as agent-based, where they can be standardized and can create some automation in planning, coordination, and control. Finally, the AI application component will give many kinds of improvement, such as automatic analysis, automatic reporting, including automatic bulletin, and finding new knowledge based on new discovered pattern. The human task in here will be on the verification and the review of the automated system. Now, let us watch a short video on ideal flow network. Yeah, thank you. Ideal flow. Network for machine learning. Ideal flow network, or IFN, is a special type of weighted directed graph where the D graph is strongly connected and the positive link weight are called flow. In each node, the relative flow must be balanced. The total inflow must be equal to the total outflow. While IFN was originally used for transportation network, it can also be used as modeling metaphor for machine learning of artificial intelligence with parsimonious data, and it can also handle big data. Items that go together can be used to train IFN for order or unordered association recognition system. The variable node value in IFN indicates the percentage of the significance of the variable useful for feature selection. The training data are read in sequence to form trajectories. We train one IFN for each category label, feeding the trajectories into the network as if part of a random walk would produce a capacity matrix. Then, the stochastic matrix, and finally, the ideal flow networks are computed. Using the trained network, when a new unseen data comes in, we can compute the probability of the trajectory of the new data for each IFN and predict the label based on the maximum argument among all of the IFN. The same IFN can be modularized into hierarchy. By setting a threshold probability, a semi-supervised system can be created to search new unlabeled data to be inputted automatically after the IFN was trained with minimum number of data. In summary, IFN theory unifies several approaches in data science, including finding association among the items and feature selection, supervised learning, and semi-supervised learning, and to form the hierarchical structure as in unsupervised learning.
Thank you, Dr. Technomo.